Okay, so, and this is going to be yours as well, guys. This, if you can add, subtract, and multiply, you can solve this pretty complicated looking polynomial equation here by factoring. And what we start with is we start by reading the clues. We're told to solve by factoring if one of the zeros is -3. Okay, so right away, if you know that one of the zeros is -3, what that means is that an input of -3 would give you this, would turn this whole side into 0. So an input of -3 for x, okay, makes this whole equation true. An input of -3 for x is a solution. Turns the left side into 0. So it turns the whole left side into 0, and that means that you have 0 equals 0 if you put in -3. That's why it's called a 0. What does that mean, though, if this turns the whole left side into 0? Well, it means that one of the factors, okay, we know that the factors are binomials. They're binomial terms with an x and then a constant. So the question is, what would the binomial look like if an input of -3 makes it go to 0? So what you would think is, hey, something plus -3, or -3 plus something equals 0, or x, x plus -3 for x plus something equals 0. So what could that something be? Well, naturally it's got to be the opposite of that, okay? So it's got to be x plus 3 equals 0. Do you see that? Because an input of -3, so input of -3 coming in, that would make this -3 plus 3, okay, which equals 0. So that means that one of our factors, okay, one factor is x plus 3. Okay, so we've already partly factored this. We knew what one of the zeros was, so we got one of the factors here. But because this is a third degree polynomial, we're going to have two more factors, so that altogether we're going to have 3 x's multiplied by each other. And that means that this could have a coefficient, this could have a coefficient, but in general there are going to be 3 binomial factors, okay, because that's a third degree term. It could be even a monomial. It could be just an x, actually. But this is how we start. We take this x plus 3, and now I want to ask you something. If someone told you that 3 is a factor of 12, okay, so what's the other factor? Well, a factor is just something numbers multiplied by each other, or terms multiplied by each other to give you another term, okay? So if 3 is a factor of 12, what's the other factor? Well, 3 times what equals 12? Well, we could figure that out by dividing by 3. Right? We divide 12 by 3 by the factor we're given, and that equals 4, okay? So 3 times 4 equals 12. Those are both factors of 12. In the same way, because we now have one of the factors of this complicated polynomial. Sorry about that. Just hit my camera person. That's Nina there. Okay. So we could just divide. We could do the same thing. Take our polynomial, 2x cubed minus 3x squared minus 32x minus 15, okay? And we could divide that by the factor x plus 3. We'll put it in parentheses. And now we have a division problem. If we can divide that by the factor we're given, okay, we will have started the factoring process, okay? But we could do this with long division, or we could do it with another trick called synthetic division. So I'm going to teach you synthetic division here. Okay? Synthetic division is where we just take this polynomial expression, we take the coefficients of the expression. Okay? We first have to make sure that all of the terms are present. If it starts with x to the third, then we have to have it followed by an x to the second. and then an x term, and then a constant. If anything is missing, if any one of these columns is missing, we have to put a 0 there as a placeholder. But right now, nothing is missing. Look, x to the third, x to the second, x and the constant. So we take the coefficients, and let's put them in order. 2, that says minus 3, so that's going to be negative 3. Minus 32, so that becomes negative 32. Minus 15 becomes negative 15. Okay? I'm going to make this kind of L-shaped algorithm here. Okay? And what we're going to put here on the left side is the 0. What is the 0 that we're given? The given 0. Okay, that's what's going to go here on the left. Okay? Well, the given 0 when we first read the problem was that one of the zeros is negative 3. Okay? If you were given the factor x plus 3, well, you could just set that equal to 0. X plus 3 equals 0. What plus 3 equals 0? Isolate. X equals negative 3. That's your 0. So negative 3. So we're going to put the negative 3 right here. And all we do, now here we go. Watch this process, synthetic division. We take the first term, we drop it down. I usually draw a little parachute here to show my students, hey, this guy's parachuting down. You see? Hey, woo! So we drop the 2 down, and now we just start, we say negative 3 times 2. What's negative 3 times 2? Anyone? Negative 6. So we put that in the next column right there. See that? And then we start again. Well, we add negative 3 plus negative 6. Because they're both negative, we add them, keep the sign, that becomes negative 9. Now we multiply negative 3 times negative 9. Okay? Negative times a negative is a positive, so that becomes positive 27. We put that up there in the next column. And now we add up negative 32 plus 27. And we have a positive and a negative. We subtract and take the sign of the bigger number. So we're left with negative 5. We multiply again. Negative 3 times negative 5. Negative times a negative is a positive. We put that up there, make it 15. And now we add these last two terms, and if we did it correctly, we should end up with 0, because we were told that negative 3 is one of the zeros, and that's what we get here. Look, negative 15 and positive 15 makes 0. Perfect. So what we do now, it's a really cool thing. My camera person's laughing here. I guess that's a good sign, so it's not putting you to sleep, right? Is it putting you to sleep?
God.
It's putting you to sleep?
No, that's just looking at me.
Okay. All right. Okay. Okay. So what we do here is we take the first term here. That's a 2. And because it was the first term up here was an x to the third, well, we divided by an x term, right? So we're left with, instead of x to the third, we bring it down 1 degree, so it becomes x to the second. So this becomes 2 x to the second, okay? And see, math makes you happy and giggly, right?
It's so wonderful, isn't it?
Okay, 2x to the second, and now this becomes minus 9. Since this was x to the second, this becomes x, minus 9x, okay? And now we bring this one down, and that was an x term, so this is just going to become a constant. This is going to become a constant here. So what we're left with is 2x squared minus 9x minus 5, which is great. We started the factoring process. So we have x, remember the first factor, x plus 3, and now here we have 2x squared minus 9x minus 5. Okay? So we started the factoring process. Now, we're almost done, but we have to factor this trinomial here. Okay? There's a couple ways we can do it, but why don't we use factor by grouping, which is the skill we learned before. So we'll take that x plus 3, we'll start on a fresh piece of paper, and we have 2x squared minus 9x minus 5. And if you remember, this is the a x squared plus bx plus c. Okay? The a term is 2. The b term is negative 9. The c term is negative 5. So we multiply the a times the c term, which is a times c. 2 times negative 5 is negative 10. So now, what we want to do is we want to find the factors of negative 10 that add up to the b term, which is negative 9. Okay, so what are the factors of negative 10? Well, we could try negative 2 times 5, but that equals 3 if you add them up. That's not what we're looking for. We're looking for negative 9. Okay, how about if we did negative 10 times 1? That's a factor of negative 10. Those are factors of negative 10. When you add them up, it equals negative 9. That's exactly what we're looking for. So what we're going to do is we're going to break up that b term, negative 9x, and we're going to rewrite everything, 2x squared. And see that b term? We're going to write it as negative 10x plus 1x. It's the same thing as negative 9x. Look, negative 10x plus x, and then we just bring the minus 5 down, okay? So it's getting a little crowded here, but I hope you can see this. That's how we rewrote the trinomial there, okay? So now we're going to factor out. We're going to take this 2x squared minus 10x plus x minus 5. We're going to take the first two terms, and then we're going to take the second two terms, okay? What can we factor out of these first two terms? Well, the greatest common factor seems to be 2x. So we're going to take out a 2x. What are we left with? We're left with x minus 5. So 2x times x minus 5 plus, what can we factor out of x minus 5? We can't really factor anything except 1. So we'll just put times plus 1 times x minus 5. And what we're left with, we now have to factor whatever we can out of these two terms. And they both have the x minus 5 in common. That means you're doing this correctly. So we put x minus 5 here. What are we left over with? The 2x and the 1. So we're left with x minus 5 times 2x plus 1. Okay? And don't forget the first factor that we were given up here, x plus 3. We bring it down here and we have x plus 3. We have our 3 binomial factors. We just factored this really tricky looking expression. Okay? But now don't forget, it was set equal to 0. So equals 0. We're going to put it on another piece of paper here. And guys, if you get this down, this is going to be a really good skill here, especially for chapter 6 in our book. 13 seconds? 13 minutes? We're doing just on time. My camera person keeps me updated now so I don't talk too much and get off task. Okay? I could use you in my classroom. You want to come to my classroom and help me teach a little?
Sure, I don't know.
Okay. How about, you're going to learn this stuff, and I'm going to put you on here, and you're going to do this, okay?
Oh,
all right.
no.
All right. So look, remember how we solved this now? It's all factored, so it's pretty simple now. We set the first binomial equal to 0. Well, we already solved that one. What plus 3 equals 0? X equals negative 3. There's our answer for the first one. What minus 5 equals 0? Well, we go x minus 5 equals 0. We add 5 here, add 5 here. X equals 5. That's our second answer. Right? Are you putting it up high so we can see?
Oh.
Okay. X equals 5. How about our third one? 2x plus 1 equals 0. Subtract 1, subtract 1. 2x equals negative 1. Isolate 2 times x. So we're going to undo the 2 with division. Divide by 2. Divide by 2. X equals negative 1/2. And we are in business. We just solved that polynomial equation that might have scared some of you, just like I got scared with that maze trick, okay? But here it is. The solutions for this polynomial equation, and there are 3 of them, and they happen to be real numbers here, okay? So here we go. Negative 3, x equals 5, x equals negative 2, and try that at home, okay? Go to chapter 6 in your book. Or if you have another polynomial problem, come on YouTube, walk through these steps, and good luck. All the best. Signing off.
Awesome.